Hello everyone, we are going to construct a rhombus using Geogebra. And the first thing you see when you open Geogebra is this drawing board on this side where it says graphics. We want to remove these axes, so right click anywhere on the board and you should see the word axes. If you do not see the word axes, when you click on that, they will disappear. If you don't see the word axes, go to graphics and on the y-axis and x-axis tab, you uncheck show x-axis and you uncheck show y-axis, and that will also make them disappear. Okay? Now to start, we are going to construct a segment with a given length. And here's how you do that. You go to your line tool, you select segment with given length. Okay, when you mouse over the tool, it gives you instructions on how to use the tool. It says select a point and enter the segment length. So when you're over here on your drawing board, you just click anywhere on the drawing board and automatically it asks you for the length. I'm going to choose a length of 7. Hit OK, and it shows you a segment AB, and this segment should measure 7. Let's check. Let's go to the measuring tool, select on the drop-down menu the distance or length, and you can mouse over the tool and it tells you what to do to measure distance. It says select 2 points or select a segment. So I'm going to select the segment, and there it gives you the measure of this segment AB. It's 7. Okay, now a rhombus has all congruent sides. That means all sides have to measure 7 in this case. So I'm going to draw another segment with fixed length. So let's go to our tool, segment with a given length. And when you mouse over this tool, it tells you that to select a point and enter the segment length. So I'm going to select point A. It asks me for the length. I'm going to say 7 and I'm done. Now, where is the second segment? Well, it's right here. If you select your move arrow and you mouse over B, notice it says point B and point C. That means there are 2 points. There's one segment right on top of the other. So I'm going to move this point over like this. So I've separated the 2 segments that I've just constructed, both of length 7. How much am I going to move this? Well, you can do this as whatever angle you want. But I do not want you to do a 90-degree angle, okay, because we will see that later when we do squares. I want you to construct a parallelogram with an angle more or less this much, okay, or you can go over this much, whatever you like. I'm going to do this much. There. Now I'm going to measure this segment just to make sure that it's 7. And it is. I'm going to move this label to the outside of the line, not inside the rhombus. There it is. Okay, now what am I missing for this rhombus? I'm missing the top segment and I'm missing this right segment over here. Now these two you have to be careful with. I need that this segment on top needs to be parallel to this line in the bottom. And I also need this segment to the right to be parallel to this line on the left. So how do we do that? Let's do the top segment first. And I'm going to use a tool that's called Parallel Line. And you go over here to this tool, you hit the drop-down menu, you hit Parallel Line. Now when you mouse over, it tells you select a point and the parallel line. Okay, so since I want my line to be parallel to this segment, I don't follow the instructions it says on there, select a point and a parallel line. I do it backwards. I select this segment and automatically you get a parallel line. You see that? Now I do hit this point to make sure that this parallel line goes through this point. Okay, now I'm going to do the same for the other parallel line. Now I want this line to be parallel to this one over here. So my parallel tool is still activated. All I have to do is select this segment so I get a line that's parallel to the segment, and then I hit this point. And there I have my two parallel lines. Now I want to know I need a fourth vertex, right? I have vertex C, I have vertex A, vertex B. Let me move these letters a little bit so that they're more visible. Here's A and here's B. Okay, I need a point right here where these two lines intersect. So to do that, I like to go to my Intersect Tool. And when you mouse over it, it says select two objects or click directly on the intersection. So I can click right here on the intersection, but be careful. Make sure that when you click on it, both lines are highlighted, you see? Or you can click both objects. So I can tell GeoGebra, look, I want the intersection between this line and this line. And look at what it does. GeoGebra automatically places a point on that intersection. Let me move that vertex a little bit, that label. There it is. Okay, now these parallel lines that we drew, these are just guides to help us find our other vertex. I want to remove these two parallel lines so that I can construct the segment CD and the segment BD, okay? So I'm going to remove the parallel lines, and to do that you hit the Move Graphics View cursor, drop down menu, Show Hide Object. When you do that, anything you click will highlight and remain highlighted. This will highlight and you click it and it remains highlighted. And those two objects are the ones I've selected to hide. So how do I hide them? You go over to your Move tool and you click on it, and there your two parallel lines are gone. All I'm left with is that vertex D. So now I connect segment CD with a segment tool. Go over here to your segments, select segment, hit point C and point D, and there's your segment CD, and you can hit point D and point B, and there is your segment DB. And there you have your rhombus. Now let's measure these two sides that we've just created. So go to your distance or length tool, hit on the segment, and there you have that this segment is 7 and this segment is also 7. Let's move our labels outside of the rhombus, not in the interior. And there you have it. You have a parallelogram because we constructed parallel sides, and you also have congruent sides, which makes it a rhombus. Okay, now I want to construct the diagonals of the rhombus and confirm that they do bisect each other, because since this is a parallelogram, we know that the diagonals bisect each other. So select your segment tool, hit point C and point B, and that creates one diagonal, and then hit point A and point D, and you have your second diagonal. There it is, okay? Notice you have two letters here, G and H. Those are just the names of these two diagonals. We can remove those. Go to your Move cursor, remember, and then you can select this diagonal, right-click on it, and where it says Show Label, hit on that, and the label goes away. Do the same for the other diagonal, right-click, Show Label, and the label is gone, just so that it's not so much information on our picture. Now the other thing I want GeoGebra to tell me where these two diagonals intersect. So again, let's go to our Intersect tool right here, and I'm going to click on the two objects that I want GeoGebra to tell me their intersection, and there it is. GeoGebra puts a point on the intersection and it labels it. Let's move that letter E a little bit over here. There it is. Now, I said I wanted to confirm that the diagonals bisect each other, so let's measure the distance. CE, right here, CE, let's measure that. And let's measure EB, right there. And do the same for AE, and do the same for DE. And what do you notice? They do bisect each other. AE measures exactly the same as ED, and CE measures exactly the same as EB. So they do bisect each other, okay? In our next video, I'm going to show you how to measure all the angles. I'll see you in the next video.